children, hearty welcome to today's module. Last class, we were discussing about the hydrogen bonding. Today, we discuss superhydrophilic and superhydrophobic surfaces. Here, we will see liquids on solid surface, explanation by using the water drop contact angles on surfaces. First, let us see behavior of liquids on solid surface. Behavior of liquids on solid surface. This little bit we discussed when we looked on surface tension. Here we will see little more in detail. When liquid drop is placed on a solid surface, there are three interfaces: liquid solid, gas liquid and gas solid interfaces. Three interfaces: liquid solid, gas liquid and gas solid interfaces. So when a liquid drop is placed on a solid surface, we have gas liquid surface, gas solid surface and liquid solid surfaces. These are the three interfaces when a liquid drop is placed on a solid surface. And here, when a liquid drop is placed on a solid surfaces, there are two kinds of forces: adhesive forces and the cohesive forces. Adhesive forces between two different molecules, the forces between the two different molecules, that is adhesive forces. Cohesive forces means the forces between the same molecules. Here, when a liquid drop is placed on solid surfaces, we have the adhesive forces between the liquid and the solid surface and the cohesive forces within the liquid. The cohesive forces within the liquid are van der Waals forces, dipole interactions and hydrogen bonding. Okay. When a liquid drop is placed on solid surface, if it is water, when it is placed on solid surface, the water will spread on the solid surface. If it is mercury or some other liquids other than water, especially in the case of mercury, it will form a drop on the surface. On the solid surface, mercury will form a drop on the solid surface. That means when mercury will contact with the solid surface, it will try to minimize the contact with the surface. That is why it will form a drop on the surface. It will try to minimize the contact with the surface. That is why it forms a drop on the surface. Mercury forms a drop on the surface because it will try to minimize the contact with the solid surface. But in the case of water, water will wet the solid surface. Otherwise, water spreads on the solid surface. Here, there is no droplet formation. It spreads when water on the solid surface, it spreads on the solid surface or it wets on the solid surface. Another aspect is contact angle. The contact angle is the angle between the liquid gas interface and the liquid solid interface. The contact angle is the angle at which the gas-liquid interface meets the liquid-solid interface. The contact angle is the angle between the gas-liquid interface and solid-liquid interface. If we look here, this is the contact angle theta. This is the angle at which this is gas-liquid interface, and here this is liquid-solid interface. So, this is the angle theta. This contact angle is the angle between the gas-liquid interface and solid-liquid interface. How we have to determine the contact angle? This contact angle is related to the force of adhesive and cohesive force, or the strength of adhesive and cohesive forces. The contact angle can be determined by the strength of the cohesive and adhesive forces. That is, if the strength of the adhesive forces between the solid surface and the liquid molecules are strong, then the contact angle will be less than that of 90 degree. When the strength of the adhesive forces between the liquid and the solid surface are less, then the contact angle will be greater than that of 90 degree. That is written here. The contact angle is determined by the balance between the adhesive and cohesive forces. The greater the adhesive forces between the liquid and the solid surface as compared to the cohesive forces within the liquid, the greater will be the tendency of the liquid to spread out over the flat solid surface, and the smaller will be the contact angle. If the contact angle is less than that of 90 degree, then water spreads on the solid surface. That time, the adhesive forces between the solid surface and the water molecules are strong compared to the cohesive forces within the water molecules. Here we have a contact angle theta, that is the angle between the gas-liquid interface and the liquid-solid interface. Here the contact angle is less than 90 degree. That means water spreads on the solid surface. Water spreads on the solid surface. Here the adhesive force, the strength of the adhesive forces between the water molecules and the solid surface are higher than that of the cohesive forces within the water molecules. That is what, since that adhesive forces are strong, the water will try to spread on the surface. It will try to increase the surface area. Therefore, water spreads on the solid surface and the contact angle will be less than 90 degree. Here, if we look, this is the angle theta, that is between the gas-liquid interface and liquid-solid interface. This angle is greater than 90 degree. That means the adhesive forces between the solid surface and the liquid will be less than that of the cohesive forces within the water molecules. Otherwise, we can see that the cohesive forces within the water molecules are strong. Because the cohesive forces are strong, what will happen? It will try to minimize the surface area. The liquid will try to minimize the surface area on solid surface. Therefore, it will exist as a drop. The liquid will exist as a drop and the contact angle will be the contact angle will be greater than 90 degree. The contact angle will be greater than 90 degree. Okay. Next, at equilibrium, the surface energies of the gas-solid interface is equal to the surface energies of liquid-solid interface plus surface energy of gas-liquid interface into cos theta. That is, gamma Gs is equal to gamma Ls plus gamma GL cos theta. This is Young-Dupré relation. Young-Dupré relation. Here gamma is the surface energy, gamma Gs is the surface energies of gas-solid interface, gamma Ls is the surface energies of liquid-solid interface, gamma GL is the surface energies of gas-liquid interface. Here, this theta, the value of cos theta, theta value depends upon the values of surface energies of gas-solid interface and the surface energies of liquid-solid interface. The theta value depends on the values of gamma Gs and gamma Ls. If gamma Gs is greater than gamma Ls, if gamma Gs is greater than gamma Ls, that time cos theta is positive. That is 0 is less than 90 degree. When surface energy of gas-solid interface is greater than the surface energy of the liquid-solid interface, that time cos theta is positive. Theta will be less than 90 degree. Theta will be less than 90 degree means the values of 0, 30, 45 and 90 degree theta will be positive. 0, cos 0 is 1, this will be root 3 by 2, here root 2 by 2, here the value is 1 by 2. All the values less than 90 degree of cos theta is positive. When surface energies of gas-solid interface is less than surface energy of liquid-solid interface, cos theta is negative. That is, theta is greater than 90 degree. When theta values of cos is greater than 90 degree, that time cos theta has negative value. Okay. Once again, gamma Gs is greater than gamma Ls, that time cos theta is positive when theta is less than 90 degree. When gamma Gs is less than gamma Ls, cos theta is negative, theta is greater than 90 degree. When theta is less than 90 degree, that time water spreads on solid surface. That means the surface energy at the glass water interface is less than at the glass air interface. The surface energy at the glass water interface is less than that at the glass air interface. Otherwise, we can see that gamma Gs is greater than gamma Ls. Gamma Gs is greater than gamma Ls. That is, surface energies of glass air interface is greater than glass water interface. In the case of mercury, the surface energy at the glass mercury interface is greater than that at the glass air interface. That is, theta is greater than 90 degree. That time gamma Gs is less than gamma Ls. We can write it as gamma Gs is less than gamma Ls. Okay. This is about the liquid on solid behavior of liquids on solid surface. So when liquid on solid surface, they have an option to spread or they have an option to exist as a drop. That depends upon the contact angle forms between the solid surface and the liquid molecules. If the contact angle is less than 90 degree, then the liquid will spread on the solid surface. When contact angle is greater than 90 degree, that time the liquid will remain as a drop on the solid surface. And all this depends upon the adhesive forces between the water molecules or the liquid molecules and the solid surface, and the cohesive forces between the liquid molecules. If the adhesive forces between the liquid molecules and the solid surface are strong, that time the liquid will spread on the solid surface. If the adhesive forces between the solid surface and the liquid molecules are less, that time the liquid will remain as a drop on the solid surface. This is about the behavior of liquids on solid surface. Now, another concept that is about hydrophilicity and superhydrophilicity. Hydrophilicity and superhydrophilicity. When water is placed on the solid surface, the water can have an attraction towards the solid surface and it can have the repulsion towards the solid surface. If it can have the attraction towards the liquid molecules are having an attraction towards the solid surface, that time we can say that the surface is hydrophilic surface. If the liquid molecules are not having that much attraction towards the solid surface or they have the repulsion towards the solid surface, that time we can say that that surface is hydrophobic surface. Everything depends on the attraction and repulsion between the solid surface and the liquid molecules. Here, the contact angle is the best indicator of this property. And based on this attraction and repulsion towards the solid surface of liquid molecules, we have categorized the surfaces as hydrophilic surfaces and superhydrophilic surfaces, hydrophobic surfaces and superhydrophobic surfaces. Let us see these surfaces one by one. First, let us discuss the hydrophilic surfaces and superhydrophilic surfaces. As the name says, hydrophilic surfaces means it is the something related to or the attraction towards the liquid molecules or the attraction of the liquid molecules towards the solid surface. That is hydrophilic surfaces. This hydrophilicity and superhydrophilicity depends upon the adhesion of the liquid molecules and the solid surface. If the adhesive forces between the liquid molecules and the solid surfaces are strong or that is greater than the cohesive forces between the liquid molecules, that time the water is pulled towards the surface and each water drop tends to increase the area of solid surface with which it can be in contact. So, when the adhesive forces between the water molecules and the solid surfaces are greater, that time the water is pulled towards the solid surface and the area of the solid surface will increase, therefore the contact angle will decrease. That means the contact angle will be less than 90 degree. When the water molecules are pulled towards the solid surface, the water will spread on the solid surface. The water will spread on the solid surface, and that surface is said to be hydrophilic surface. Hydrophilic surface means water-loving surface. Hydrophilic surface means water-loving surface, and this property is termed as hydrophilicity. This property is termed as hydrophilicity. So, when we learn this hydrophilicity, we have to remember the force, adhesive forces between the water molecules and the solid surfaces are stronger than that of the cohesive forces between the water molecules. Then, therefore, the water molecules are pulled towards the solid surfaces and it spreads on the solid surface, and the contact angle will be less than that of 90 degree, and that surface is said to be hydrophilic surface, and this property is said to be hydrophilicity. I hope you understood what is hydrophilicity. Now, the examples of hydrophilic surfaces are glass and ceramics. Glass and ceramics are examples of hydrophilic surfaces. Glass and ceramics are examples of hydrophilic surfaces. Now, let us see what is superhydrophilic surfaces. If the adhesive forces between the water molecules and the solid surfaces are so great, the adhesive forces are so great compared to the cohesive forces between the water molecules, and the contact angle theta is less than 90 degree. The contact angle theta is less than 10 degree. The contact angle theta is less than 10 degree. Such surfaces are said to be superhydrophilic surfaces, and these properties are termed as superhydrophilicity. Superhydrophilicity. Okay, this is when we come to the definition of superhydrophilicity, when the adhesive forces between the water and the solid surfaces are so great and the contact angle will be less than 10 degree, then such surfaces are said to be superhydrophilic surfaces, and the property are termed as superhydrophilicity. This superhydrophilicity property was discovered in 1995 when it is firstly observed in titanium dioxide when it is irradiated in sunlight. We have an example of superhydrophilic surfaces, natural example for superhydrophilic surfaces, that is the pitcher plant. Here in the pitcher plant, the adhesive forces between the water molecules and the solid surface in the pitcher plant are so great than the cohesive forces between the water molecules. Therefore, it can spread on, it can remain, the water can remain or it can spread on the solid surface, and the contact angle is less than that of 10 degree. Therefore, the superhydrophilic, the pitcher plant is the superhydrophilic surfaces. We can design the superhydrophilic surfaces by some physical methods like laser treatment, UV radiation, then physical vapor deposition and spray coating. And we have some chemical methods also used to design superhydrophilic surfaces. Some examples of superhydrophilic surfaces are silicon, titanium dioxide, and a mixture of silicon dioxide and titanium oxide. All these are examples of superhydrophilic surfaces. So when we conclude this hydrophilicity and superhydrophilicity, in the case of hydrophilicity, the contact angle is less than 90 degree, and in the case of superhydrophilicity, the contact angle is less than that of 10 degree. Here we have the contact, when the contact angle is less than 90 degree, that surface is hydrophilic surface. When contact angle is less than 10 degree, that surface is superhydrophilic surface. This is about the hydrophilic surface and superhydrophilic surface. When we look into this hydrophilic surface and superhydrophilic surfaces, especially we have to remember two things. One is the adhesive forces between the liquid molecules and the solid surfaces are so greater than the cohesive forces between the liquid molecules in the case of hydrophilicity. And if it is so great, that is superhydrophilicity. Then coming to the contact angle aspect, if the contact angle is less than 90 degree, that is hydrophilicity. If it is less than 10 degree, that is superhydrophilicity. Now let us move on to the another property, that is hydrophobicity and superhydrophobicity. Hydrophobicity and superhydrophobicity. That is water hating. That is water hating. This is just opposite to the hydrophilicity and superhydrophilicity. Here the strength of the adhesive forces between the solid surface and the liquid molecules are less than that of the cohesive forces between the liquid molecules. Since the adhesive forces, the strength of the adhesive forces are less than that of the cohesive forces within the liquid molecules, what will happen? The surface area will reduce. Therefore, that liquid will remain as a drop on the solid surface. And the contact angle will be greater than 90 degree in these cases. The contact angle will be greater than 90 degree in these cases, and the water will remain as a drop on the solid surface, and such a surface is said to be hydrophobic or water hating. Hydrophobic or water hating, and this property is termed as hydrophobicity. In the case of hydrophobicity, two things we have to remember. One is the adhesive forces between the liquid molecules and the solid surfaces are less than that of the cohesive forces between the liquid molecules. The contact angle is greater than that of 90 degree in the case of hydrophobic surfaces, and this property is termed as hydrophobicity. The examples of hydrophobic surfaces are plastics, especially the polythene, polypropylene and Teflon. All these are examples of hydrophobic surfaces. We have seen that these plastics and all having, they are not water loving, they are water hating. Now, let us move on to the another property, that is superhydrophobicity. In the case of superhydrophobicity, the adhesive forces between the surface and water are extremely low, such that the contact angle theta is greater than 150 degree. Such a surface is said to be superhydrophobic surface, and this property is termed as superhydrophobicity. That is, the adhesive forces between the liquid molecules and the solid surfaces are extremely low, compared to the adhesive forces between the liquid molecules, and the contact angle will be greater than that of 150 degree. Such surfaces are said to be superhydrophobic surfaces, and they are termed as, and this property is termed as superhydrophobicity. We have the natural examples for superhydrophobicity. They are in lotus leaf, colocasia leaf, and rose petals. When water is all this in leaves, that is, if the water is in lotus, it will remain as a droplet. It can freely roll off in the lotus leaf, colocasia leaf, and in rose petals. Because of the superhydrophobicity property, the water droplets can freely roll off in the leaves of lotus, colocasia, and rose petals. We can design the superhydrophobic surfaces by adjusting the roughness and by suitable coatings. We can adjust the roughness of the surface by suitable coating material, and we can design the superhydrophobic surfaces. So when we come to the superhydrophobic surfaces and hydrophobic surfaces, we have to remember two things. When the contact angle is greater than 90 degree, that is hydrophobic surface. When the contact angle is greater than 150 degree, superhydrophobic surface. So these hydrophobic surfaces and superhydrophobic surfaces are forming when the adhesive forces between the solid surface and the liquid molecules are less than that of the cohesive forces between the liquid molecules. When the contact angle is greater than 90 degree, that is hydrophobic surface. When the contact angle is greater than 150 degree, the time the adhesive forces between the solid surface and liquid molecules are extremely low compared to the cohesive forces between the liquid molecules. Those surfaces are called superhydrophobic surfaces, and this property is termed as superhydrophobicity. This is about the two properties. They are hydrophilicity and superhydrophilicity, hydrophobicity and superhydrophobicity. These properties are, when we conclude these properties depends upon the adhesive forces between the liquid molecules and the solid surface. If the adhesive forces between the liquid surface and the solid surface are greater than that of the adhesive forces between the cohesive forces between the liquid molecules, that time we say that is a hydrophilic surface. The contact angle will be less than 90 degree. If the contact angle is less than that of 10 degree and the adhesive forces are even stronger than the cohesive forces between the liquid molecules, that surfaces are said to be superhydrophilic surfaces, and that property is termed as superhydrophilicity. When we come to the hydrophobicity and superhydrophobicity, the adhesive forces between the liquid molecules and the solid surfaces are lower than that of the cohesive forces between the liquid molecules, and if that adhesive forces are extremely low compared to the cohesive forces between the liquid molecules, that surfaces are said to be superhydrophobic surfaces, and this property is termed as superhydrophobic surfaces. In the case of superhydrophobic surface, the contact angle is greater than 150 degree. Case of hydrophobic surfaces, the theta angle will be greater, the contact angle theta will be greater than 90 degree. This is about hydrophilicity, superhydrophilicity, and hydrophobicity and superhydrophobicity. In this module, we saw that the behavior of liquids on solid surfaces, especially we saw the hydrophilicity, superhydrophilicity, hydrophobicity and superhydrophilicity. With this, we conclude this session. In the upcoming session, we have a question answer session. Thank you.